Yeah, I'm really thrilled to introduce Maria Jensen from Recycling Electronics for Climate Action. She's the co-director of that organization and one of the founders. And also John Kearney is also on this chat or on the call here, and he is also a co-director. Maria grew up in Cannon Falls, Minnesota, and I don't know exactly. I know she went to school in Norway for recycling and all kinds of things. I think of her as an unlikely proponent for recycling, but an absolutely terrific and fantastic one who knows her stuff. And she's been very active working at the legislature, trying to pass bills, which she'll get into. But it's my great pleasure to introduce Maria Jensen. So, Maria, are you there?
Hi, everybody. I hope I don't have too much background noise. I went to one of my favorite cafes, which Nicola might be on your list, Reverie Cafe, and it's during the day, but right now there's a lot of people here, so I had to move my spot around a couple times. But here I am. Yeah, so I'm gonna just share my for me. I actually made them this morning, so a little bit of new content. Some stuff that I'm really, really excited to share. And we function as a business association for electronics recyclers here in Minnesota. So we have members that own recycling and refurbishing companies across the state. And we advocate at the legislature for better laws around electronics recycling. Really with the focus and the of that are used in our electronics. So that's who we are. Today, I want to talk a little somewhat familiar with the topic. And after going on the Sherco tour with a bunch of you, I know that you know a lot about circularity and the environment. So I might go quickly through some of that to leave extra time for probably a bunch of really possibly nitty gritty, difficult questions from all of you at the end. But yeah, I want to just cover the basics. What is electronic waste or e-waste? What is circularity? I have a video to show for you guys. And then briefly on some policy action for circular economy for electronics here in Minnesota. So I'm sure I can't really see raise of hands, unfortunately, but I'm sure most of you have heard of the term e-waste before, but a couple definitions for you. It's just an informal name. Another useful way to describe them is really anything with a battery, a cord, or a circuit board, which actually ended up being the definition that we used for our legislation. So now I do actually want to see a raise of hands. I can't see everybody, but how many of you have heard of one of these terms, either circular economy, recycling economy, or linear economy? The linear economy is kind of the status quo, right? So this idea of extracting material to make something, right? In this case, we're talking about physical objects, and then use them, and then when they're done being used, we dispose of them in either a landfill or waste has environmental justice impacts, right? So the extraction, the manufacturing, the use, and the disposal um, all have the opportunity to produce environmental degradation or harm humans. Circular economy is the idea that you just take once, and then you have that material going into new products continuously. And this is not something that most or really any products have fully achieved. And so, kind of in between the linear economy and the circular economy is this idea of the recycling economy, which is not the end goal, but it is kind of where. But most products are somewhere in between there. And I won't give you a full analysis of where electronic waste is on this spectrum because there's so many different products and materials that go into each kind of product that would take probably 4 hours to have that conversation. So I won't dig too deeply in there, but I will say electronic waste and battery recycling is somewhere in between linear economy and circular economy. And what we're doing as RICA is really trying to push a local circular economy for electronics and the materials that go into them. So questions before I move on there. Wonderful. Yeah, so I'll just walk through the status quo. Well, I shouldn't say status quo. What does a linear economy look like for electronics? So we have our extraction phase, and a lot of you have heard about mining for platinum, palladium. especially in places like the Democratic Republic of the Congo. And if you haven't, I just make that suggestion to you. Maybe look up mining in the DRC to learn more about some of the poor labor laws or broken labor laws and poor working conditions and just in general environmental justice issues related to the mineral extraction, especially in the DRC. Then our next step of the life cycle here in our linear economy for electronics is shipping and manufacturing. And just fun fact, for pretty much all physical objects that are manufactured, the manufacturing step of their life cycle is the largest greenhouse gas. Even if it's going to a landfill or being thrown in a trash incinerator, it's really that manufacturing step that is the biggest environmental impact. So if you can reuse something and not recycle it. If you can keep it living for as long as possible, that is the best way to recycle that object. And you have its use. That's your economy. It's going to be disposed of and not recycled. And most commonly, you're going to be talking about landfills and contamination in the soil, water, and air in the surrounding area. And it's going to be toxins like mercury, cadmium, chromium, flame retardants, and lead that you'd be mostly concerned about. Not all waste goes to landfills. This is a picture of the trash incinerator in downtown Minneapolis. And in the bottom right corner is a microwave, big environmental and environmental justice issues with burning electronic waste here. Some of the health effects associated to being exposed to these chemicals are decrease in lung function, spontaneous abortions and premature births, DNA damage, and a decrease in educational. It's not just health effects that are damaging in a linear economy situation. We're also looking at huge dollar amounts that we're losing from damage when electronics are discarded. So this was a transfer station that burned down in Blaine, Minnesota in 2018, and it was worth $20 million. And that happened because a electronic device was discarded and ended up there, and the lithium battery that it contained started on fire and caused a catastrophic loss for that facility. These are two local trash hauling trucks. One's from St. Louis County, and one is in St. Paul, actually just in front of McAllister College. And they each had a battery fire on them in the past couple of years as well. And this is an extremely dangerous situation for workers, as you can imagine. And this is from the Rice County landfill fire. I don't know if some of you heard about this. This was a couple of years ago. After that happened, I started asking landfill operators how often they have battery fires at their facilities. And the most common answer I got was every day. So they're looking at spot fires. That's what they call them if they don't end up in an uncontrolled situation. If they're able to put it out that same day, then they call it a spot fire. And they're saying that that happens on the daily. So this is a part of the story of a linear economy for electronics. So moving on to a more positive note, and I want to start with, for the circular economy of electronics and what that looks like, I want to start with this video, which I'm really excited to share because I just got footage of inside of a battery recycling facility in Nevada, and it's been quite the journey to try to get any kind of footage or information about the battery recycling process. So you are some of the first to see this footage, and I'm really happy to share it. But what I'm hoping is it just kind of paints a picture for you all of what it looks like to work in the electronics recycling economy. So, and it doesn't have any audio. I can try to do my best to kind of walk you through. This is their staging area. So these are all pallets and pallets and pallets of lithium ion batteries. And here they're using a pneumatic system to load cells from EVs. So these are EV batteries that they're lifting. They're extremely heavy, so they're not doing that by hand. Here you see some folks just disassembling them because they want to take the cells out before they shred the material. And these are the individual cells of the, I believe, EV batteries. I'm actually going to this facility in a couple of weeks, so I will have a lot more details to share and hopefully more accurate information the next time I present this. This is a machine that does the material separation, or sorry, the mechanical separation of the cells. So the batteries go in there and it's basically grinding them up and just liberating all of the different materials that go into it. And then they're just taking that liberated material and putting it into their hydraulic system. So the next step, which it'll show, uses an electrolyte solution to further separate those materials. And this is a hydraulic process it's showing here. Doesn't give us a ton of details because this is really their secret sauce. And they're not going to tell us exactly how this process works ever because that's how they make their money. So. And then here, after it goes through the electrolyte solution, it's put through these filters. And what you're seeing right here is what's called black mass, and it's very rich in cobalt, lithium, graphite, some nickel, I believe. But again, I'll have to get more details on what their black mass contains at the end of their process when I visit them in a couple of weeks. And these are just super sacks getting filled up with the material after they leave the filters. And at this point, the material is dry and ready to be shipped out to be used in a new battery. It's not just black mass that they're creating. They're pulling out lots of different metals to pretty pure percentages. And these are some of their end products. And again, this is one of the things I'm going to have to get more details on what their end products contain exactly and how much of those end products actually go into new batteries. This is the same company, Redwood Materials, installing batteries at what I think is a solar site, because they are actually a battery manufacturer themselves, which is kind of a good sign because it's just showing that they are closing the loop there within their own company. So it's definitely possible to have somewhat of a circular economy for batteries. There's still lots of questions to find out. How much material is wasted in this process? Is it a 1-to-1 ratio? You recycle one battery and then you get one battery out, because that would be a true circular economy, right? So still lots of questions. This is a really new industry. It really took off from the Inflation Reduction Act spending. And yeah, so still a lot to come there, but all right. So how am I doing on time here? 7:37. Okay. So I want to talk a little bit about what we're doing to promote the circular economy for electronics here in Minnesota. And it kind of started out in 2023 when we did this study with Iron Range Partnership for Sustainability as well as Macalester College. And what we did was really we wanted to answer the question, how much of the metals that we need for the clean energy transition could we get from electronics, and specifically talking about just our electronic waste here that's generated on an annual basis in Minnesota. Um, so what's different about that than, for example, if you look at the Global E-Waste Monitor, which is kind of what people rely on for this type of data, what's different from our study versus the Global E-Waste Monitor is that we were really looking at potential, not current extraction rates, because we wanted to know, like, what's the total potential if we could reach 100% circularity, what would that look like? So just a clarification there. So if we were able to recycle 100% of the electronics and get all of the metal out of them on an annual basis in Minnesota, just to put it in context, there would be enough silver to produce 440,000 solar panels on an annual basis and enough copper for 155,000 EVs. And that's about a $3 billion value total of all the different metals that we looked at, which there were about 60 of them, 60 different metals. And that's the solar panels and the EVs are just an example to kind of give an order of magnitude. So then, of course, the next question is, how do you get there? How do you get to 100% circularity? There's a lot of things that go into it. Like I mentioned, manufacturing is the biggest environmental footprint when it comes to electronics. And so a repairable design is really important. And there's a lot of things that are standing in the way of that right now. Secondly, is a recyclable design. So things like removing glue from devices and not gluing everything together, making the battery removable by hand so that you're not creating as much of a bottleneck for the recyclers. Not putting toxins into our electronics. People have been looking into reducing the amount of PFAS or flame retardants that go into our electronics, plastics especially, to keep our workers safe and just to keep the environment around the recycling facilities healthy and safe as well. Investing in technology, much like you saw in the video, that the IRA was a great example of that. Getting lithium-ion batteries recyclable is really something that's happened in just the past 4 or 5 years. And ultimately, the most important thing is to reduce our consumption. But in Minnesota right now, kind of what we're looking at a state level policy is collection, because right now we're only collecting about 20%. This slide is actually old, and our new data says that it's probably more like 19-20% collection of the almost 300 million pounds of electronic waste that we generate here in our state each year. So that means 80% of our electronics are either still being stored in our homes, or they're ending up in landfills or incinerators. So we've really focused on this issue as a bite-sized piece, as something that we can do that would positively bring us towards a circular economy for our electronics, and tangibly help our members as well, which are the recycling facilities. So we have the 100% electronics recycling bill, and we've worked on this now for two different legislative sessions. We actually started in 2023, came back in the 2024 session, and then in the 2025 session we had kind of what looked like a very feasible, passable bill. And it's really just the political context of the moment being a split legislature that was really our sticking point. But at this point, we have the Pollution Control Agency on board, we have the county governments on board, and a wide coalition of nonprofits and for-profit businesses behind this idea. And the general concept is to ask producers, well, not ask, but tell producers to fund the recycling of electronics. And the reason for this is because once electronics enter into the recycling facility, the private market can take care of the rest, right? At that point, it's a commodity that can be shredded. The valuable material can be extracted from that, and by selling that valuable material like gold, silver, platinum, palladium, the recyclers can make money, right? Where the system gets broken without any support is the collection, right? Going out into rural Minnesota and collecting the material from residents and businesses out there. That's where the economics of the situation don't really make sense for the recycling industry. So that's where we want to bridge the gap here and create this public-private partnership with the state stepping in to say, okay, producers, you're creating this material, you're making a profit off of it in our state. So in order to sell electronics into our state, you're going to have to close this gap here for us here in Minnesota, and make sure this material is properly collected and sent to our recyclers. So yeah, that's what we're working on. That's the 100% collection bill. I could totally go into more like of a policy breakdown if you all are interested in that, but I'll just stop here for now to see what you all are interested in, what questions you have.
Thanks, Maria. That's fascinating. And the video was really interesting. All right. Well, does anyone have questions? Tim does.
And Maria, I was just wondering, where is the Redwood Materials plant that you're going to visit located at?
Yeah, so it's near Tahoe, Nevada,
Okay.
just outside Tahoe.
Maria, oh, yeah, go on ahead, Tammy.
Hey, fantastic presentation. Just a couple questions. Number one, is, looking at the recycling, it appears as though, I mean, there could be danger for humans that are processing it. Are there discussions or ideation strategies underway to implement the use of robotics for some of these extractions? And then if we do, then that could probably speed up the extraction time frame. I mean, what's the end-to-end time frame? So let's say you're gonna take a phone apart, right? I mean,
Mhm.
how long does that actually take through the whole process?
Yeah, so I can't answer that question for redwood materials, but a local recycler in St. Cloud once told me 4 weeks from the point of collection to the point of selling the shredded and sorted material. So because that's what they do at their facility. So if that gives you somewhat of an idea, because they're not running well, it depends on the facility, but in general, recyclers are not running all of their processes all the time. They're focusing on one thing at a time, oftentimes. And their shredders aren't running 24/7. So they generally, because there's a big bottleneck in recycling of prepping the material. So I know you saw in the video there were those people doing that like very manual process of pulling the cells out of the battery, which I would assume that could be automated fairly quickly because EV batteries are pretty standardized, but the rest of the electronic waste stream is not standardized whatsoever. So there probably will always be a some level of manual labor involved in prepping those devices for a shredder because you don't want a lithium ion battery going into a circuit board shredder because it's not a wet process or a process that's void of oxygen. So you're going to have a fire. So you want to make sure that the batteries go in the battery shredders and that everything else goes in the everything else shredder, basically. And that's the biggest bottleneck. But everybody is automating as fast as they possibly can. So Redwood has lots of automated processes already in place. But even small local recyclers, like the one I mentioned in St. Cloud, they're automating their process to sort through different kinds of circuit boards so that they can get the best price for their shredded circuit board material at the end of the process. So, and that used to be, I mean, I've been working with them since 2020, and back in 2020, it was all manual. And now they have a robot sorting probably at this point, maybe 25 categories out of, I believe it's 50. So they're getting there and they're teaching their robot to do that. So I think, yeah, the answer is it's rapidly being automated and they're using robots for as much as they can.
Yeah, Jeremy?
Hey Maria, so in lieu of the federal government not supporting or actively probably fighting these types of businesses, do you have any sense of how economically viable they are without federal support? I know that's a big question, but with redwood materials, um, could these businesses stand on their own in your estimation?
Yeah. So it depends on what type of business you're talking about. If we're talking about the folks that are the typical e-waste recyclers, they've been around for a long time, and the material that they're really making money on is circuit boards. And they've been doing that without any kind of subsidy or any kind of help for a long time. So I don't worry about that industry. What I do worry about though is the battery recyclers, which are really still in their kind of in somewhat of a nascent stage. I'm sure Redwood would not say that, and they would say that they would say very confidently to you that they are totally economically viable and at no risk of going under anytime soon, no matter what. But just as a bit of a skeptic, I am I still holding my breath a little bit for the specifically the lithium ion battery recyclers, because they are so new and so many of them, probably 100% of them, as far as folks based in the US, have received government dollars to get started. So we are still waiting to see, are they going to make it? We've seen some fail already. If you want to learn more about that, you can look up Li-Cycle. I'll type that in the chat. But we've seen some of them fail already. So we're definitely concerned about that and hoping for some of these larger companies that have made it pretty far to keep going. Other types of battery recycling has also been around for a long time, like lead acid batteries. Not worried about that. They've been making money on that for a while without any government help. So
I have one more follow-up question, if that's all right.
Go for it.
I just saw, I don't know if I saw that correctly. Was there approximately 300 million pounds of electronic waste in Minnesota? Was that number accurate? Or did I read that wrong?
that's right. Yeah, 300 million pounds almost
And is
generated
that,
on an annual basis. So it's based
Yeah.
on 46 pounds per capita in North America. So it's a pretty broad statistic. It's nothing specific to Minnesota. But in general, North America, based on the population, it's about 46 pounds per person. And that
Okay.
doesn't mean that you yourself, you're generating 46 pounds a year. It's also all the businesses and anybody who's not any entity that's not a person, is all of that waste is all divided by the population. So
Yeah, I got it. But it comes out to 46 pounds per person approximately. And that's probably equivalent to how much is purchased, how much electronic equipment is purchased per person.
correct.
Because
Yeah. Purchasing data is
Oh,
much
wow.
easier to get a hold of than waste data. Waste data is always very sketchy and very out of date. You're always looking at something that's it's always behind. So whereas purchasing data can be what happened today. So
Yeah, makes sense. Thank you.
Hey, it is Tammy. Can I ask a quick question that tags on to Jeremy's question? Do you have any statistics in the last couple years on the increase in waste? I'm thinking about how fast technology changes, and I just think about my own family's use case, and we're swapping out um, you know, devices, and I would say at a rapid rate. So have you seen the numbers increase of waste being accumulated as the years go on? Is that attributed to, technology changes and newer devices?
yeah, absolutely. In fact, they say that e-waste is the fastest growing waste stream in the world. And that is despite really rapid dematerialization. So if you think of your old TV, your old tube TV, right? How much does that weigh? Like 40 pounds, 30 pounds? Am I in the ballpark? Something like that, right? Whereas now your LED or LCD screen, that only weighs like 5 pounds, right? You pick that up, it's really light, it's mostly plastic. That's dematerialization, using less material for the same or similar product. So despite that each individual item is getting lighter and lighter very rapidly, the e-waste stream is still growing at 4% per year, which makes it the fastest growing waste stream in the world.
All right, Sarah?
Yeah, this is Alex. Are there
Alex.
certain products that by design are easier to recycle than others?
I'm not sure if I missed the last part of the question. Was the question just, are there some items that are easier to recycle than others?
Yeah,
Or
like
yeah,
especially when it comes to batteries, like are there certain chemistries of EV batteries or are they incorporating recyclability into the design of some of these products?
yeah, this could be probably an hour-long conversation, but in general, yes. Some items are designed in a way that you can remove and separate the materials very easily, and others have just like generally the things you're looking for. Let me phrase it this way. The things that you're looking for the recyclability of an electronic device is, can you take the battery out easily? is there a lot of plastic? If there's a lot of plastic, that makes the economics of recycling very difficult because plastic is not worth anything to the recyclers. Is there glue in the device that's going to prevent recycling or make recycling more difficult? Are there any hazardous items that if they go through a recycler, they're going to cause health impacts for the workers? One example is a vape or a e-cigarette. Those are one of the worst items possible or imaginable for recycling, because not only do they have a lithium ion battery, which is very flammable, right? Very volatile, that is encased fully in plastic, so that can't be removed from the device to be recycled. But it's also encased with nicotine, which is a hazardous substance. And in fact, the manufacturers will tell you that there could be a lethal dose of nicotine in the devices if you're a worker that's recycling them and trying to break them apart. So they're not recyclable whatsoever. There are no vapes, to my knowledge, that are being recycled in any meaningful way. They're generally going to hazardous waste incineration because of their design. The what it's made of is recyclable, but the way that they designed it makes it impossible to recycle. So that's kind of what you're looking for recyclability. And then standardization is another one. So like an EV battery is highly recyclable because the economics are easy because there's tons of valuable material in there. And they're pretty standard. There's like a few different types, and they can automate processes to disassemble it before it gets shredded. So that would be an example of something that's pretty easy for the industry to tackle.
Great, thanks. Yeah, I see that, some of the new designs are encapsulating all the cells in these batteries with some pink like goo to help with thermal dissipation. So I was just curious if that solves one problem, it creates more, but it's good to hear that their
Yeah.
EV batteries are highly recyclable.
Yeah, that coding sounds like a nightmare. I'll have to ask Redwood about that when I'm there.
Maria, this is Greg. And I don't know if you could answer this or John, but I know you've also been talking about like the recycling copper campaign and trying to increase copper recycling by 20% and what that would do in terms of reducing the need for copper mines. We were talking about the boundary waters a little bit earlier. Could you speak to that for just a second, or John, if that's better?
Can I talk about it, Maria? Yeah, I can talk about it. Well, the most dramatic example we give is that, so if copper is highly recyclable, copper can be recycled infinitely. All the copper that's been mined is still above ground and recyclable since day one. Anyway, so in the boundary waters, I think they're now proposing 3 copper mines and a couple of copper nickel mines. But anyway, if we increased our copper recycling in the United States by 20%, right now we're at about 33%. The European Union's at about 60%. If we increased our copper by 20% to 53%, it would eliminate the need of 14 or 13 of those mines, the output for 13 of those mines. And right now, 99% of the copper that's being mined in the United States is being mined by 17 mines. So eliminating the need for 13 mines is fairly dramatic. So yes, we are working on a campaign it's been a neglected campaign. We're putting together, what we really want to do is develop a communication network with all the people in the state, in the region, in the country, internationally, who are dealing with copper and nickel challenges. Because people don't realize what tremendous potential there is for recycling copper. The copper industry understands it, but people who are fighting copper mines don't have a good understanding of it. So we'd like to change that.
All right. Well, thank you, Maria. That was a really interesting presentation. And thank you, Greg, for the introduction. So have a good month, everyone. Stay tuned for upcoming things. Don't forget to volunteer for the Eco Experience booth, the MRES booth at the State Fair, and see you next month.